Okay, this should work. Okay. Now, if I have r theta coordinates, okay, then we had this function get point, okay, which returns a pair xy. Okay, so now this is something which I am not sure whether you have used these things or not, but pairs work exactly like, or in general, tuples work exactly like lists in terms of accessing. But you can also, the nice thing about, unlike in a list, in a tuple you can actually assign it. You can say x comma y equal to 3 comma 5. X will be 3, y will be 5. So you can take names. Okay, so basically what I would do, I mean, but not get point. So one way of doing this would be, so you basically you get your x and y and do the same thing, right? So you say right, so you first say x my y, which is not, doesn't look very elegant, but anyway, my x my y, okay, is my get point. Now you can always invoke your function on yourself because it's p dot get point, right, or q dot. So if it is yourself, it is self dot get point. So any function that you want to invoke, which is defined in the class on the current object. So if you want to use a function, what they call method, which is defined in a class to define another class, right? So you might have a basic function, you might have another function which calls it. For instance, supposing you have a matrix, you might write a function which adds a row, gets the sum of a row. Then you might want another function which adds all the elements in the matrix, but that might just be a loop which for each column or each row adds the row and then adds it up, right? So you want to call self dot add row. So in here I would say self dot right. So here I am using the fact that I can do this thing. And what will happen if I do an assignment where a and b are any value, it doesn't necessarily have to be, this goes here and this goes there. So this is allowed. Okay. And in particular, this is allowed, which is a great feature of Python, right? So you can say xy equal to yx and swap two variables without using this famous temp.
And what happens if we leave out the parentheses?
If we leave out the parentheses, then I think it's not technically treated as a tuple type, but I'm not sure.
So all the x, y value
I don't know. I don't know if you can write x comma y equal to y comma x without putting a bracket around it.
Seems to work
In Python.
wondering the limit.
Yeah, I don't know, but maybe implicitly it takes it, but it's, I mean, this is what it means at least. So there is a sequence, so there are these sequences, right? So the sequence that we have seen is a list, then a string is also a sequence in Python. So all sequences have the same notation, so that square bracket I gives you the ith element from 0 to length minus 1, then I colon j gives you that slice, the segment from I to j minus 1. So all of these things work whether it is a list or it's a string or it is a tuple. So if I have an n tuple and I want some coordinate 4, then I will just say square bracket 4. Right? So that's another way of doing this. Other way of doing this would be say my x is self dot get point square bracket 0. My y is self dot get point square bracket 1. But you can abbreviate that because you want both of them anyway like this. Right? So this is the other thing which is not obvious is that you can actually put names on the left hand side inside the tuple and assign them to the names. You're not just copying a tuple as a tuple, but you're actually internally copying it to the names that you have used in the tuple. Okay, so that's a very nice convenience here. So same way you can say, oh, maybe I should. Right, this nuisance is only because I don't have x and y explicitly. I have to calculate it. So either I have to take r and theta and calculate it myself, but get point has already been doing that. Right, so why not just use it and now proceed as blah blah blah. Right, this returns square root of my x minus px squared plus my y minus p. Right. So is this clear? So so the only point was that you have to do a little bit of extra work because of the r theta thing. It's nothing more than that. Right. Any question about this assignment? Right. And so similarly, in an analogous way, right, if I had to do that translate, which was the other one, right. So this was the function. So if I had this xy version, it would be very easy. So in the xy point, I would just say, always remember you need the self, but you also need the name of the function. Sloppy. So you take my current x and update it. Take my current y and update it. Right? So this is how I would translate an xy point. I just update my attribute to include the new quantity that I am adding to it. Right? So there's nothing more to be done, and this point will be changed in place in some sense. So you don't create a new point. Yeah.
So why if I just say self equal to self the point of self dot x dx, self dot y dy, just that doesn't work.
No. So what are you exactly? What syntax are you using?
Instead of these two lines,
Yeah.
writing that
Point dot self.
self equal to point of
No, see, so okay, so the thing is that point as a name, okay, capital P point is just a class description. So it's a template, right? It's just a description of what are all the features available in a typical point. So it's not it doesn't have any other. It's a different type of thing in some sense. It's not directly an executable thing. It doesn't store any information except it's like a blueprint by which you can instantiate a concrete copy. So now I have made a copy P or I made a copy Q, then within the object P, when I call a function, self refers to itself. But for the global point, there is only a blueprint. So self means which point, because there may be one, there may be several. So self has only a meaning if you call it in the context of a specific point. Right? So I will do this complicated thing a little bit later. So what happens if you have variables which are shared across all points? I mean, right? Then you can say something like point dot, because that same point, that variable is actually, whether it is there in P or Q, it's the same value. I mean, it's difficult to imagine why you would want it. As I said, one example is like this web page thing which says this page has been accessed so many times. So supposing you have a function which just refreshes the page or displays it, right? But every time you display it, you want to update a counter so that the next person gets a new value of the counter. Then that counter has to be basically stored across all the web page accesses and displayed at that time and persist, whereas the display that you actually see on the screen is temporary too. So this window will be showing different something from that window. Right? So but in that context, it makes sense to use the class name for the variable. But if you use self, it will always be a dynamic. I mean, it's a kind of self only makes sense first of all if you are sitting inside a point. So you must first identify a point. So that is why when you say P dot something, then you have identified a point. Now when you say P dot something in that function that you are calling, if it says self, it knows it's called in the context of P. Right? So even this argument self that you see here, it's as though I was saying translate P comma x dx comma dy. I mean, when I say P dot translate delta x delta y, it is internally, you can think of it as translate P comma, it's like a 3 argument function where one argument is put at the beginning with a dot, and that gets mapped to self. So but unless there is a mapping for the self, this thing will not work. So maybe that is the problem that you are facing, that you need to have that fixed object before you can start manipulating the self. Right?
Maybe this question also was, could you maybe just instantiate? So I think he wants to self equals point of and pass it these two parameters to construct.
So that I don't know. So that will create, first of all, that is not the desired effect. and that will it's okay. This okay. We'll come back to this, but this is a problem. Okay, so this is a problem.
The self equal to anything.
Yeah. So anything like this will not work. So I'll note this. This is a very important point. Actually, if this is your confusion, this is a very important point, and it's a general thing that you need to be aware of. Okay. The same thing. It doesn't matter with self. It matters with this list also. If you pass a list to something and inside that you say L is equal to something else, then you're doomed. The outside list is not going to change. Right.
But
So it's a
inside the class I can certainly make, like I can make those objects instant.
you can instantiate objects inside the class, but you can't change what self is pointing to. So that is the moral of the story. So you can make new objects, but self will not change. So from the outside point of view, P will remain whatever it is. You cannot change self inside the thing. So it's even if it's allowed, it will not reflect in any change in the P that you called. It's like trying to ask the function to make P point from here to there, and that you cannot do from inside the point function. You can only do it from outside the function. Right. So I'll come back to this. It might become a little clearer when we talk about this names, values, how they are pointed to, and okay. So, but that's a point. So now I just wanted to say that. So therefore, for r theta, you have to do the same thing as before. Right. So you'll do. So the easiest way I can think of, is to do that earlier trick. Right. So get my x and my y, right, and then you have to set. So remember that you have a in addition to the init, you have a set point, right, which allows you to pass an x, y, and it will convert it back to r theta. Right. So then I would just say, so set point is different from creating a new point. It is an existing point. It is like that copy point that we just wrote, except you are giving an explicit x, y to it. Right. Right. So this should work.
But it's also okay to say self.r equals.
You can, but then you have to compute it again. I'm just saying that you want to rewrite that thing which says self.r is equal to square root of blah blah blah, or you can just make sure that it's generally a good idea to use code that you already have. So in fact, coming back to this, I would say that in that earlier example that we did, right. So if I say copy point this, right, I can also alternatively I could have written it as what? So this might be very obscure, but
Okay.
because I have to pass it xy. So I get the xy from P by getting its xy, and then without doing anything, I pass it back to self to say set yourself to it. Right, so this would also work. Okay. So this is a style of programming which is popular in other languages like Haskell and all that. So this is called functional programming. That is, you try to create small functions and then you call everything as a function of a function of a function, and you don't write too many assignment statements. Right? So you don't use intermediate variables unless you really have to. Right? So sometimes it is clever and easy to figure out, sometimes it's very obscure. So it depends on what you're used to thinking of, whether this is easier or the other is easier, or you want to, even this can be made more transparent by saying, px is equal to px comma py. So the same thing if I write it alternatively as this has the same effect as the previous line, except that I created what you might call unnecessary names px and py, so that I can put them back. Okay. Okay, the other thing I'm not very sure is I have to sort of check whether passing two things is the same as passing a pair of two things and stuff like that. So there is some type checking which has to be done. But a functional programmer would prefer the first line to the second line if you can get away with it. Right? But it may be less confusing to use these intermediate variables just to be sure that you know what, or if later on if you need px and py, anyway this is good. If you're using it only once, then whether you need to give it a name or not is a matter of style. Right? And I'll just keep all these things around. Okay, so that brings us to the second question, which is more a philosophical question about programming languages. Okay, so we've done both these things, right? So you agree that there are many ways to do it, and you can choose whichever one is the best for you. So the question is, should it be acceptable to say things like, for example, if I'm using distance, right, then should I just take p dot r, p dot theta, compute its xy coordinates, supposing I didn't have this get point. Right? Should it work or should it not work? Now, one of the things that I mentioned last time is that generally the goal of having this object-oriented programming style is that you have this black box and you should not rely on the names of things, because as we explained even with point, if you are initially implementing point with xy coordinates and move to this polar coordinates, then the user of a point sees no difference in the functions, but would see a difference if they are explicitly using x and y as attributes outside the function, right? So there is a subtle difference, because here the question is who's using the r and theta. The person who's using the r and theta is a function or person in an abstract sense. Okay, the thing that is using r and theta is a function inside point itself. So presumably when you rewrite point to use x and y, you will rewrite this function also. Right? So this is a general philosophy that is there in programming languages other than Python, which doesn't enforce this type privacy and publicity of this thing. Right? So in a language like Java, the general rule is that any object of a class can see the private parts of any other object of the same class. Right? So if you write a function like this, you don't have to go through this torture of using a function to extract its part and then reconstructing it and all that, because the assumption is that this function which accesses the other thing is inside the same class. And why will it change? Only because somebody decides to re-implement that class. But when they are re-implementing the class, this function also has to be re-implemented. So it is their job to figure it out. It's not an external person's code which will go wrong, but your own code which will go wrong. So you as the designer of the class will presumably make sure that all the functions in your class are consistent with each other. So if you change something in one part, you have to change everything else to reflect that. External functionality is different. I mean, in this case, you'll preserve it and no external person is going to use that. It's only by calling a function here, this calls something there, that calls something there, that's fine. Right? So this is generally okay if you are inside a class, but it would be wrong if you had two classes, say you had point and you had matrix, and point was able to access some internal things of matrix, because that would be like something which is disjoint. Like because now the update of another class will not necessarily be reflected in an update of this class. So within a class is generally considered acceptable to look at private attributes and use them like we did in that copy point. Okay, but across classes it is frowned upon, simply because that implementation might destroy your code. Right? Okay, so one of the things that Python has in general for function are optional or default arguments. Right? So you might want a function which does something. There's an additional qualifier which you want for it, but that qualifier may or may not be present. Right? So the typical example used in Python tutorials, I'll just illustrate it. So you know this function. And this is important because all Python input comes as a string. Right? So if you want to read a number from the keyboard, you need this function, otherwise you will never get the value, right? You need to take, so typically if I want to read something from the keyboard, right, so supposing I say x, and I look at x, what is the type of x? So this is the difference. Okay, so this is not how Python 3 works. So in Python 3 you need this thing. Okay, so here it seems to be smarter than, is it because I've already used it? Yeah, so Python 2 seems to look at the thing and scan it for itself, because in Python 3 I can assure you this doesn't work. So if I say x plus 3, it will say I cannot do anything about this, it's a string. Okay.
So you just did x equal to input and
Huh? Yeah, if I say x equal to input, then in Python 3, everything that is typed in is always rendered into the variable as a string. Then you have to convert it to int, float, or whatever, and it's your job to figure it out, right? So if I say if I say int x, in this case it works. If I say x is equal to input and I say 88.0, okay, then x is now 88.0. Now if I say int x, it will say sorry, this string is not an int, I don't know what to do with it. No, because of Python doesn't, so Python 3 does not even bother to figure out whether the string is valid or not. If it has a decimal point, it's not an int. Okay, if it's a sequence of digits 0 to 9, then it's an int. Anything else is not an int. Maybe with a minus sign in the beginning. Okay, that's all. Right? So Python 3 has a very different philosophy in input and output. So you have to be a bit careful if you are switching Python. So as I have found out just now. But anyway, the point is that, what are they saying? I say that you have this, right? What about this? Okay, now you see some extra information. It is an invalid string because I am in base 10. So actually, int has an optional second argument, which is a base. Right? So if I want to treat this as a hexadecimal integer, I can do so, provided I provide the base, but if I don't provide the base is 10. Same way if I say int 10, it is 10, but if I say int in binary, it is 2. Right? So this feature is there in Python, that you can give. So one way of thinking about it is that you are giving an argument is optional, but probably the correct way of thinking about it is there is a default value for an argument, and if you don't provide the argument, the default value is taken. In this case, the default value is 10. Okay. So the way you usually do that, I mean the way you do that in Python is,
But output is always base 10.
yeah, the display is given in base 10. It's the value, I mean otherwise it will be very confusing. So the output is the number as in base 10. So you have something like this, okay, and then it takes a string, and then usually it takes a base.
How do you look up the help for a function in the interpreter?
I think you just say help.
Question mark.
Yeah, so this is the thing.
It just shows the code source.
So I don't know if this helps. Right, so now you want, so this will require that you call this function always with 2 arguments, right? So in general, that's a general feature of any Python function, right? If you define function f of a comma b, then whenever you call f, you must provide 2 values, one for a, one for b. But we want to have the thing where the base value, if it is not provided, is something which is taken by default, right? So you can make that happen. So base must have a value because it is assumed it will be used somewhere in the function, and Python, as you know, gets confused if you produce a name which doesn't have a value. So the value in a function for the arguments is taken at the time the function is called. So if somebody has not given you a base, you should have a value for the base. So you have to provide it somewhere. You don't want to provide it inside the code because then every time the base will be overwritten by what you write. So you write it in the argument. Right? So you say you say def int as before, and then when you give the second argument, you give a value. Okay, so this is like an implicit assignment which happens sort of think of it as this happens before the function is called. Now I provided arguments. If the argument comes, it comes and it overrides base. If it doesn't come, then you use 10. Okay. Now, so is this clear? This is how you would do this. So if we go back to our earlier thing, so we want to so that process of calling, constructing is the process of calling this point with argument. So when I set up a point, it's called, so that function init is called a constructor. Okay. So earlier we had this compulsory thing, right? And so let's say this is just a 2D point. I said self dot x. Okay. This would be how you. Now I want to make this optional and I want to make it 0, 0. So the crucial thing is if you want to make it optional, you must have a default value. Right? So instead I just write the same constructor as and now I mean nothing else changes, that's the point. Self dot x is still a, self dot y is still b, but if the user did not give me a and b, right, then it becomes 0. So this actually allows the user to give me a and not b, but does not allow the user to give me b and not a, right, because if the user gives me a second argument, I mean one argument, then it will be the first one, right, not the second one. You understand?
In your polar implementation, you need to add a line, if a equals 0, then theta equals pi by 2.
Okay, good point. I should remember that.
I learned from hard experience.
You should, but this is often the case. Right, so this is clear. So there is, so you have to follow some obvious things. So now if some things are optional, some things are compulsory, then obviously the compulsory things must come before the optional, because how does it, Python doesn't know, right? Supposing I say f of a is optional, b is compulsory. Right? Now I provided one argument. Now is the argument that I have provided supposed to be taken with the first thing or the second thing? Of course in this case it would know, but I mean if you start mixing these things up, Python will get confused, right? So the rule in Python is that if you have a set of arguments x1 to xk which are compulsory and then y1 to yl which are optional, then it must be in that order. That is, all the compulsory things must come before all the things. So Python knows that you must get at least k arguments, and then if you give a k plus 1, it will be taken for y1. If you give a k plus 2, it will be taken for y2 and so on. And whatever arguments are missing will be always at the end of your sequence, and those will all be given optional values. Okay, so all optional parameters must come after all compulsory parameters, which is true here, right? So the optional parameters come at the end of the list. You can't then after B produce a new argument in your definition which must be there. If it must be there, you must move it before.
You cannot say A equal to 0.
You cannot say A equal to 0 and then not give a default for B. See, if I don't give a default for B, it means B must be provided. So it says this, so in this particular case, it cannot be that the x coordinate is optional but the y coordinate is mandatory. That is not allowed. Okay. Whereas in this definition, as I use it, Python will allow me to give any prefix of this. Either I can give both x and y, or I can give only x, or I can give neither. If I give both x and y, of course it will overwrite whatever I've written here. If I give only x, y will be 0. If I give neither, both will be 0. But I can't say keep x as 0 implicitly but set y to what I'm giving you. There is no way to do that. Okay. You could possibly do that. I don't know, maybe it does allow you to say, give a function and say y equal to. Okay, sometimes it does allow that, but I don't know if Python allows that or not. One way of finding out is see, but in order to do this, again, the problem is you need to know what is the name of that argument. See, normally the name of the argument, you don't care whether somebody writes def of this thing as a comma b or c comma d or e comma f. As far as the outside world is concerned, this is the same function. They are just some names for the parameters. But if you want to say set the e parameter to this and set the f parameter to that, then it's the same problem as looking inside a class. If tomorrow that guy just rewrites it or just uses some search replace and says replace all e's by ee and f by ff, then your program will no longer work because you have asked for e to be something. But if the person who designed the function has changed the name of the parameter. So in general, I think it doesn't allow it, but we can find out, at least for this one. It does. Okay, so it looks like. But what happens if I say y? Right. So you can call a function in Python explicitly by the names of the parameters in any order. But if you're using the positional order, then the positional order must always be fixed as compulsory first and then optional. Okay. But this is a dangerous thing to do if the code is not stable. Right. So tomorrow if that guy, why, there's no reason why the argument to int should be called x. It could very well be called s. Okay. So this is not a good thing to rely on in general.
Presumably, if you're using the function, you need to know what parameters to pass anyway. I mean, presumably reading the documentation.
Yeah, so the documentation can tell you, I mean, it depends on how you interpret the documentation. It could say that the first parameter is the x coordinate and the second parameter is y coordinate, which is how you should interpret it, rather than the first one is x, which is the x coordinate, and the second one is y. So the name of the parameter is what we are using, and that is unstable. Whereas the interpretation of the function, I agree, that must be clear. You must know. So usually this is something which is good for if you have control over the code and you're doing your own code. But if you're using somebody else's code and you don't have control, next version 2.7.9, if they change x to y, then you'll be in trouble. Right? So you should be a bit careful about this. Right? So that's one of the things. Okay, so I was going to do, okay, so let's, I won't do inheritance today. Instead, I will talk about this other issue about okay, so I was doing this experiment over coffee and it works, so let's see. So now supposing while creating the points, I want to remember all the points that were ever added. Right? You say P equal to point, Q equal to point, R equal to point, but somewhere I want to know that there are 3 points which have been added. Okay? And more importantly, I want each of these points to be able to look up these 3 points if necessary. Okay? So my toy example for that is right. So among all the points which currently exist, wherever they are, okay, tell me which is the nearest one. I already have a distance, I assume. Okay, so I just want to find the one which is the shortest distance away. But the crucial thing is, how does a point P, which is sitting inside, it has its own existence, it has its own, say, let us assume we are in this XY world, it has its own X, has its own Y, right? So it's a simple enough object. But how does it know about the other points if they are not given to it? See, P dot nearest is going to be a function which is going to ask it to implicitly compute all these things.
You want all the objects which are in the same
Yeah.
class.
Yeah, so we want something which is updated every time this class is used to construct a new object, and that something must persist and be available also to all the classes, all the objects that were created. So it's a variable which is persistent and available. It's not enough to just as an outsider be able to look it up, but even inside the class these things can look it up in order to compute. Okay, so so the solution is that, so if you define a variable inside a function, like if I say def something and inside a function, then if I use a new name ij, all these kind of things that we typically use for loops, that's perfectly fine. But usually the semantics of those variables is that when the function exits, those values disappear. They are no longer available to me. Right? So we want a value which is not like that. Okay? So the trick in this case is that you define attributes which are outside all the functions. But inside the class. Okay. So as an example in this case, so I am doing this for xy because it's much easier. I will say just simplicity, I will just keep a list of all points. Okay, so I define a variable outside the thing. I have to give it a value, otherwise Python doesn't, there's no way of, unfortunately, in Python, because there are no declarations like in C or Java or something, you can't say I want a list of this type, but currently it has no value, it's empty. Right? You have to explicitly create an empty list to tell it that this name means that. Now, here is where, right, if I write this init, so one of the things I will do when I do init obviously is to set up the point itself, because this is a new point which is being created, right. So let's use the version we just wrote with these optional parameters. Okay. So the first part of it is the old thing, right. So I'm using this xy because distance is easier to compute, right. Now I also want to register in some sense the fact that this point has been created in that persistent variable, right. So I have not told you right now this is a list of what.
So that is run the first time this class is
Which?
called, that all points?
Yeah. So that all points, yeah, it's run the first time it is called.
And not.
Yeah, and it's that, yeah. So this thing happens magically, or when it could even be, I'm not very sure how Python does it, but it could even be, say, in order to process this, it's not even necessary to call the class. It has to, when you say import, it has to read all these definitions and assimilate them. So at that point it might be done.
Because you'd assume that when the class is called, it jumps to the init straight away.
Yeah.
Not.
Okay, so maybe, yeah, so let me just complete this and then so now what I want to do is I want to extend this. Okay, so now okay, so list has a slightly different connotation, but in general if I had an I outside, right, if I write a function, I mean normally one doesn't do it, but if you write an I out, if you have an I outside and I call a function, then the I inside will override the I outside. So I want to say I want that the outside all points to be updated. I don't want to create a new list called all points which is inside the init, right? So this is where your original notation will work. You say give me the all points defined inside the class point. Okay, that is that guy. Okay, and now add to it, okay, this current point. So I am going to actually use this list as a list of points. Okay, a list can be a list of anything, right? Right. So this I claim will take the current point and append it to this list.
You mean class point?
I mean class point, very much so.
Doesn't seem to work. Oh.
It works in the coffee room.
So now all points will be like.
So all points now, when I come to the next init, when I append it, the first init's effect will be there, I claim. Okay, so let me do a simpler example which I hope I have saved somewhere. So I did all sorts of so this is all unnecessary, but okay, so this is just a trivial class. Okay, so all it does is, the only purpose of this class is to define a count variable which persists across each time I call the class. It doesn't have, the objects have no internal value other than the fact that when they are created, the thing that they do is they increment that variable and then they print. Okay, so now so this is just some trick to say that I am creating a list of 8 points. Okay, and okay, so when they are created, nothing happens. Sorry, it's when you call this function inc on a point, then it updates the thing. So I create 8 points, okay, and then on each of those points I call this increment function, right? So when I call it on the first point, it should print 1 because initially it is 0. I call the second point, it should print 2 and so on. Okay, and then just to answer your question as to what happens, okay, that I just wanted to make sure that it continues. So if I create an 8 more points, then it takes off from where it was. It doesn't go back and reset it to 0 at any point. Okay, so each,
Running 3.5 or 2.7?
this is 2.7. Okay. No, so this actually has a main. Okay, so the main function just does all this. So I can just run this code as it is. Right. So it does keep that count and print it out each time. Right. So this is the static variable. So now coming back to our thing. Right. So now, yes.
So the difference between both and executive.
Huh?
In the top.
Yeah.
Yeah, so what you called that.
Yeah. No, so the static dart.py actually is an executable Python thing because so this is going to be executed. Right. So anything which is outside the function will be executed. So I have created a, so basically it's executing this this part. Right. So this Python file has a class which contains an inc, okay, and then it has a function which calls that class, and it has a function which calls that function.
What is the default path?
Yeah, so basically what is happening when I say Python of this is it's trying to go outside everything and start from here. So I could have put all this out and it will execute this whole thing, but I wanted to make sure I can change all that without, that's all. So for instance, if I did not have this line, so if I commented out this line, right, then there is nothing will happen, right? So there is just nothing. But if I say this, I can run main. Right? So it's just running main from. L should be in this. Is in which case?
Just in this one, because you are.
So L should be.
You don't have any objects.
So L is outside, right? Yeah. So unfortunately L is a function which is thing which is inside main. So maybe what I should do is what is the best way to do this? So, but L would be a sequence of objects. I mean, it will be a list of objects. Right. It's a list of some obscure memory address of an instance of static var, because I kept appending one more static var to it. So it's a list of objects. Okay, so we have a couple. I have to have early lunch and take a 1:15 schedule. So what I want to do with this is I want to then define. So I'll probably come back and do this next time. But my goal is to now define this nearest neighbor business, right? So what I will want to do is I need that inside a point I need to be able to access this, which we know we can do, because if we can append to it, we can access it. So it's not very complicated. Maybe I'll just do it right now. Scan all the points in this thing, okay? Compute the distance to each. And return the nearest one, the one whose distance is minimum, right? So this we can easily do, because as we have seen in it, if I say point dot all points, the function has access to all points. So similarly, we can have a nearest function which does this. Okay, so I have written a particularly obscure version of this. So
Actually, I don't understand. If your all points is initialized inside the class, why is it global? Why is it visible outside?
it's not visible outside, it's visible to each point in the class. You can't call it from outside.
Okay, I see.
Or from outside you can call it point dot all points. That should work, but I've never tried it.
Can we just see that again? Then self dot all points, which one?
One second, let's go back to the other example, which is
It's got an attribute of self. It's got an attribute and object of class.
Oh, okay, it's an attribute. I see.
Just to
Sort of scroll in class.
also keep this. Okay, so I've kept that println inside the main for whatever good reason. But now I go back to this import version, right? From static import star. Okay, so it prints out all this thing, then prints out your L. Now the question is, what is static var.count? So you can get it from outside the class. So this is now tied not to one instance of the class. Okay, if I say, no, L is lost. Anything is, I have no other way of getting it.
So it's an attribute of the class.
Yeah, so it's like an attribute of the class, so you use the class name to get it. So this is an example of this is math.py. Right, so pi is a constant which is defined in math as something which is, presumably you should not say math.py equal to 3 and proceed. I don't know what it does. But in this case, I can actually say, I think static var.count equal to 15. Okay, this is a dangerous thing which Python allows, which should not be allowed.
Can you show the code again?
Yeah, I'll send it to you. You can mull over it ad infinitum.
So you call it with, you can't say self dot.
See, here the point is, if I don't use static var, then it becomes an integer called count inside inc, which has no other status outside. If I say self.count, it becomes an attribute variable of this instance and not of any other instance. If I say static var.count, is referring to that count. So it says all three are different.
So can you make it forget for it? Like, forget this attribute. Suppose
Forget meaning what? You can reset it. In general, Python has a thing called del, which makes you forget anything.
so suppose I have some attribute which operates in each term, and I create its few instances, then that attribute value will be updated. Like,
Yeah. But if you do it this way, yeah. But you could have another function which just resets it, right? So you could have an object. I mean, one way is to have a way of creating an object with an optional parameter which says reset, which resets this thing. And if you don't say reset, it creates a new. I mean, you have to work a way of. Okay, but now coming back to this other thing. Okay, so just wanted to show you this. What is that function called? Okay, so this is the thing which I wrote. Okay, so we have this all points. And then, as I said, when you create a point, you append it. Okay, then you have this old thing, the set point, get point business. Okay, then this is my distance. Okay, now I want to define the nearest point to myself. Okay, so if first of all, it's the nearest point which is not equal to me, right? So if the length of this list is 1, if I am calling it from inside the thing, is at least 1 point, because p is a point, right? So if there is only 1 point, that's myself, then none is a special Python value which doesn't mean anything. Okay, so I only want to make sure that the list has at least 2 elements. Now bear with me. You take you create the list of all points. Okay, but you sort them, and this is something which is again some optional thing. So you sort it by distance basically, right? And having sorted it by distance, the 0th one will be yourself, because the distance 0. So you take the first guy.
What is the copy sign?
Copy sign is, I was looking, see, I'll explain this line a bit, but so Python does not have a sign function, as I found out 5 minutes ago.
Oh,
Okay, so it doesn't have a function which returns -1 if it is -0, if it is 0 and +1. Okay, copy sign is the nearest thing, and copy sign returns a float. Then you have to convert it to an int, because this sorted requires a function which returns a negative int or a 0 or a positive int. I just tried to say this distance. I want a to be smaller than point A to be smaller than B if the distance to A is smaller than distance to B. So then the convention of this function is, if it is negative, the first one is smaller. If it's positive, the second one is smaller. And if it's 0, they're equal. Then it says, oh, you're giving me a float, I want an int. So I said the only way to convert this float to an int is to get the sign, but there's no way to get sign in Python. So then you have to do this bizarre copy sign produces minus 1.0 or plus 1.0, and then okay, so ignore that issue. But it's doing essentially that, it's going over all points, computing their distance, sorting them, and taking the not the first value but the second value.
So Sage really is pointless because we just say less than
Yeah.
or
Okay.
even min. Or
Yeah. So this amazingly works. Okay. So as I okay, so if I say so one thing is I can, if I say point dot all points, I'll again get some list of points, okay. But I can say right, oops. Right. This hopefully will give me something sensible. Okay. And now if I say p dot nearest, what was it called? Nearest point. Okay, then I get this, but if I say p dot nearest point get point, which is what I want to do, then I get 4, 5. But if I say, okay, but if I say q dot nearest point get point, it is not 3, 4, but the other guy. So to this limited extent, it works. See, it's 3, 4, this is 3, 4, 4, 5, and 3.5, 4.5. So the next 2 points are nearest to each other. Okay. So I'll put out this code along with today's things, and you can, and we'll start from here next time. Yeah. So one big thing which has to be answered is your question about why you cannot set self inside an object. I mean, that's a big question, right? So Friday we'll continue.
Also, I think many people are Sage for this Python stuff.
Yeah, so
use
this
the Python interpreter by typing Python on the command line, and so there are a few things to figure.